All right, today, last section, chapter 6, section 6.6, properties of kites and trapezoids. Test on Tuesday. Now, as you look at this here, kites and trapezoids, last couple of days we talked about parallelograms. What were some of the special parallelograms? Rectangle, square, and rhombus. Why did we not talk about kites and trapezoids then?
Because it's different.
Because they are not parallelograms.
Yep.
Kites and trapezoids are just quadrilaterals. They are not parallelograms. Okay? A kite is, however, a quadrilateral with exactly two pairs of congruent consecutive sides. If a quadrilateral is a kite, such as FGHJ, then it has the following properties. There are two unique properties here. The first one, the diagonals are perpendicular. What's that similar to? A rhombus. A rhombus had diagonals perpendicular as well. So kite's similar to a rhombus in the sense that it has perpendicular diagonals.
Diagonals.
Like F to H and G to H. Like if you go through there, does that make sense? Okay, so there's the diagonals. And here's the other part. In a kite, exactly one pair of opposite angles is congruent. Okay, so notice a lot of times it's like the wide angles, so to say. But they are congruent. Now what also happens here is, you see this line FH? That's actually an angle bisector as well. So those angles are congruent. Does everybody see that?
Yeah.
Okay, so it's also an angle bisector there, something important. This line right here, GJ, is that an angle bisector?
Yeah.
No, that is not an angle bisector. So there's just one diagonal that's an angle bisector, the one that goes through the middle of it there. All right? We also have a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. If the legs of a trapezoid are congruent, the trapezoid is what's called an isosceles trapezoid. Think about it. An isosceles triangle. What's it mean to be an isosceles triangle? Two sides the same, right? What's it mean to be an isosceles trapezoid? Two sides are the same. Could I ever have the two parallel sides be the same? No, not in a trapezoid. Okay, in a trapezoid that would not happen. All right, so recognize that. That'd be a parallelogram for us. Down here, isosceles trapezoid theorems. In an isosceles trapezoid, each pair of base angles is congruent. If a trapezoid has one pair of congruent base angles, then it's an isosceles. So what that means here is, if this is an isosceles triangles, my base angles down here, those would be congruent. And if they're congruent, then the angles at the top, they'd be congruent as well. All right? And then if a trapezoid is isosceles, if and only its diagonals are congruent. So if the diagonals are congruent here, that means it's isosceles, or vice versa. If it's isosceles, the diagonals are congruent. All right? Last thing we'll talk about here. Because these sides are parallel, what do I know about these two angles? What would they add up to? 180. Because they're parallel, aren't these same side interior angles right here? So they'd add up to 180. Same thing on the other side. What about these angles right here? They'd add up to 180. All right? Do I know anything about this angle and this angle? Only if it's an isosceles triangle do I know anything about the angles up there. All right? So you can't say like these add up to 180 or anything like that. So let's look at these first couple questions here. Number one. In kite ABCD, BCD is 98 degrees. So BCD is 98 degrees. ADE is 47 degrees. I want to find each of the following measures. First one says I want to find DAE. So here's angle DAE right here. Now some of you look at that and go, psh, I have no idea, not a lot going on there. We have to remember some of the properties about a kite. What do I know about the diagonals, where they intersect?
90.
They intersect all 90 degrees angles, right? So do we all agree this has to be 90 degrees right here? What type of triangle do I have right here? Don't I have a right triangle? Yeah, I have a right triangle here. So if this is 90, and that angle is 47, could I take
43
180
degrees.
minus 90 minus 47? I can, and when I do that, I get, what'd you say, Reed?
43.
You end up with 43 degrees. This angle right here, 43 degrees. Okay? Does everybody see how we did that? We got that property because we know these angles in the middle are 90 degrees. Okay, that's where that comes from. Next part. I want to find angle BCE. So I want to find this angle right here. Chris, what are you thinking?
34.
It is not 34. You're thinking, sir?
49.
It is not 49.
40 divided by 2.
They're not, that one is not a bisector.
What?
This line right here is the bisector.
Oh, shoot.
Okay? Now, let's think about it. In a kite. Okay, let's say I draw a kite here. Ooh, that's a really bad kite.
It'd be 43 since it's.
Okay, I'm really bad drawing kites, I guess. There we go. So, in a kite, we're going to know about these two angles right here.
Wouldn't those be
They're congruent, right?
opposite?
So these two are.
So, isn't angle C the same as angle A?
Yeah, alternate interiors.
So, if this one is 43 degrees right here, because this one is 43 degrees, it has to be the same over there, I could do 98 minus 43, and when I do that, angle BCE comes out to be 55 degrees.
Wait. Could
Okay.
it be 43 because of opposite.
They're not parallel, bud. If they're parallel, yes. I understand. Oh, I understand where you're going now. They're not parallel. Does that make sense, though? If they're parallel, that would work. I got you. But does everybody see? This angle right here is 98 degrees. So I take the 98 minus 43 because this angle right there is 43, and that's where I get 55. So same thing, this angle here would be 55 degrees. And the last one, I'm going to erase here to help the last one. Okay. I want to find angle ABC.
94.
Okay. It is not 94. I already found out this angle right here is 98 degrees, right? If angle C is 98 degrees, what's this one right here? 98 degrees. We said this angle right here is 47. What's the angle right next to it going to be?
47.
So isn't this angle right here 94 degrees?
Yeah.
In a quadrilateral, what are all the angles on the inside add up to?
360.
So I would do 360 minus 98 minus 98 minus 94. And when I do that, I come out with ABC actually equals 70 degrees. Now that is just one way to work those problems out. Okay, there's multiple ways to work these out. Like for instance, we got down to, this one was 55 degrees right here, we said, right? Well, isn't this the right angle right here, right?
Yeah.
So couldn't I find this angle, which was 35, and then double it? Because the other side has to be 35 as well. Okay, there's a lot of different ways to work some of these problems out. The goal is to find a way that works for you. Triangles, quadrilaterals, congruent, parallel sides, find some of those ways. All right? Let's try these two. In a trapezoid, okay, in a trapezoid, we have two parallel sides. Now, this is an isosceles trapezoid. Does everybody understand why it's an isosceles trapezoid? Because two sides are the same. So, if this angle is 124, what's angle K going to be?
124.
Angle K is going to be 124. And because I have parallel sides, what do I know about these two angles right here? They add up to 180, right? So what's angle J going to be, Quinn? 56 degrees. Nice job. In 5, in trapezoid EFGH, FH is 9. Find AG. Again, what type of trapezoid do I have here? I have an isosceles trapezoid. So what do I know about these two diagonals? They would be the
Same.
same.
As AG.
Oh, so
So if FH is 9, what's EG going to be?
EG would be 9.
9. So how would I find AG?
2/3, so divided by 3.
What? How would I find AG? Let's backtrack here. Remember, think about it here.
Do the thing where you do
If FH is 9, FH is 9. That tells me AG has to be, okay, AG here is 9.
Oh.
If EA is 6.2, what's AG going to be? 2.8.
Yeah, 2.8.
So I just do 9 minus 6.2,
6.2.
and I get 2.8. A lot of you guys are trying to think of centroids where you're dividing by 3.
Yeah.
That's where we're coming up with that. That's for centroids, not with trapezoids. Okay, so yeah, that's just understanding diagonals have to be the same, so I add or subtract and I can find that missing part. All right, take a couple seconds, try these 3 on your own. This is just a little bit information on kites. All right, number 6. Ty, what do you say here? Angle D. What's angle D going to be? 118 degrees. Why? Angle D is going to be the same as angle B, right? Nice job. Okay, 7. What's AB going to be? Oh, let's go with Luis. What's AB going to be? 3.25. Nice job. And 8, CD. Hannah, what's CD going to be? What'd you say? 6. Nice job. Does everybody see opposite side or the consecutive sides are congruent? Great. Now comes a little bit tougher problems with this.
Oh boy.
Same idea in a sense. Looking at a kite, try and find the missing angles. So again, BAC is 35. And BCD is 44. Take a couple seconds, try these 3 on your own. Number 9, who thinks they got number 9 here? Trent, what are you thinking? 55 degrees is correct. How do we find that?
Since it's a right triangle,
Yep.
so you take 90 plus 35.
Yep. 180 minus 90 minus 35 would give me angle B. Nice job, Trent.
Oh, can you just took it like 90 minus 30?
I could have just done 90 minus 35 as well. Yep. 10, angle DCA. Who thinks they got angle DCA? Spencer, what are you thinking? It is 22 degrees. How'd you find that? Yep, just half 44. So DCA is 22 degrees. All right, last one, ABC. Who thinks they got ABC? What'd you say?
110.
Oh, wait, I get it in like 1 second.
What do you think, Ty? We're looking for ABC right here. Okay, I'll help you out.
Oh, I got it.
Oh, it's not an angle, but
68.
Nope. Let's talk about here. This angle right here is 35, right?
right.
Now this angle down here is 44. Does everybody agree?
Yeah.
Which makes this angle right here 22.
Yeah. Oh wait, so we just add the 2.
Don't have a triangle right here?
Yeah, so add the 2 to minus 180.
So 180 minus 35 minus 22. So basically it's 180 minus, is that 57?
Yes.
123.
Wait, why'd you do 35?
Because ABD was 35. It gave me that? Or sorry, BAC, sorry, ABC or BAC was 35. I gave that angle right there. And then I found out this angle was half, so 22. So I'm looking for the third angle in that triangle. And that's where I got 123. So again, a lot of this today is using some of the old skills we've learned about triangles, bisectors, those type of things. All right? Next part, take a couple seconds, try these 2 on your own. Some trapezoids. All right, Becca, I think you got them both there. Angle Z, what do you say? It is 98 degrees. Why, Becca? Wouldn't angle W be 82 degrees as well if angle X is 82 degrees? Because it's isosceles trapezoid, which means then those 2 have to be supplementary. And the last one, if Km is 7.5 and it says Nm is 2.6, Well, I want to find KL, or NL, sorry. Who thinks they know what NL is going to be? Chris?
4.8.
Isn't it 4.9?
Oh, so I did have it.
Because how do we know that? Well, we can subtract here. If this is 7.5, 7.5 minus 2.6, so that means this one is 4.9, which means the other one is 4.9 as well, because they're congruent. Yep. And last thing we're talking about today is the trapezoid midsegment theorem. Okay, think about midsegment. We talked about midsegments in triangles before. Let's talk about midsegments in trapezoids. In a midsegment, what's it do? It goes from the midpoints, and it's a line. So notice it goes from midpoint to midpoint. To find this, what it says is take half of the two bases. So for instance, let's say MN is 10 and LP is 20. What would AB be? 15. What would you do? 10 plus 20 divided by 2.
Divided by 60.
Let's go another way here. What if I told you this? What if I said LP is 8 and AB is 6? How would I find MN?
Ooh, don't tell me.
It'd be what? It'd be 4. Why?
Well, it goes from 8 to 6, so that's minus 2.
Did I have minus 2? So what am I going to do here?
First subtract.
I'm going to subtract 2 again. Remember doing that like the midpoint formula? We talk about midpoints, we add and divide by 2, and then if you have like the midpoint and endpoint, you see what the difference is and do it again. Same thing here. Okay?
Sick.
So, no, let's skip these two real fast here. Let's take a couple seconds, try these two on your own.
Bless you.
All right, number 16, Anderson. What do you say about number 16? 21, how'd you find that, Anderson?
Right, well, figured out 26 is 10 more than 16. 16, like, half of that would be 5, so you
Yeah.
5 to 16.
Or you can say, yeah, difference here is 5, so difference there is 5. Nice job. Gentlemen, quiet down. Year 21. 17. If the bottom's 5.5, the middle's 7.5, what do you get, Chris?
9.5.
9.5. How'd you find that, Chris?
And 2. Because 5.
You add 2.
Yes, 2.
So I add 2 again. It's got to be 9.5. It's got to be same distance. Nice job. Take a couple seconds. Try these two on your own. When you do number 18 here, you'd want to add them. So 4.3 plus 14 divided by 2. Anybody know what you get?
9.1 something.
9.15. In 19, if you think about it, what's the difference? Aren't you subtracting 12.1?
Yeah.
So I subtract 12.1 again, and I get
10.8.
10.8.
Oh, yeah. We were supposed to say
Here's your assignment.